Hello everyone and welcome. Today we're going to learn how Goodwill Industries ensures 24/7 data availability using N2WS and AWS. Today's presenters are myself. I'm Mike Ruiz, a Partner Solutions Architect with Amazon Web Services. We also have Sebastian Straub, Systems Engineer with N2WS. And we're very pleased to have Briley James Yetter, Director of Technology, Goodwill Industries of Southern New Jersey and Philadelphia, joining us on the panel today. Today's agenda, we'll try to keep it simple. I'll begin with a discussion of backup and recovery on AWS, how to do backup and recovery, and why the features of the platform support backup and recovery. We'll also hear about Cloud Protection Manager by N2WS for AWS workloads from Sebastian. And then we'll hear from Briley as he discusses Goodwill Industries of Southern New Jersey and Philadelphia and their use of N2WS to protect AWS workloads. So learning objectives. We want to learn how to identify and implement best practices for building a resilient AWS environment. And as a preview, we're going to talk a lot about best practice for backup and recovery on AWS. We want to learn how to implement a cloud-native backup and recovery solution with the feature set of an on-premise solution and why kind of those on-premise features matter today in an AWS environment. And we also want to learn how to rapidly recover from outages. And we'll see some of that from Sebastian as he discusses the N2WS solution. So without further ado, backup and recovery on AWS. So by way of introduction, what do customers tell us are some of the common backup and recovery challenges that they experience both on-premise and with AWS? So one, and I think we're probably all familiar with the challenges of manual backup on-premise. I think it's a fairly typical motion where we introduce a new service or an application or set of systems. We may begin with manual backup, improve that over time with some tooling, maybe with some scripting, and then as our needs scale up, as we need to meet compliance objectives or reporting objectives, or we need to introduce more people into the process, we may look to an enterprise solution. I think it's also typical that we see as we operate environments over the long term that we have all of these solutions in play at the same time. So we have a mix of manual, semi-automated and fully automated backups, and maybe even different technologies from different vendors to accomplish all of these tasks. So this becomes difficult to manage. What may be kind of less understood or less appreciated is folks that come to AWS may experience the same journey. So AWS is pretty easy to operate. We expose a lot of our services through the console. It's pretty easy to make snapshots. And so it's pretty tempting to rely on these manual backup processes in the cloud as well. But as our needs scale up, we're going to have very similar problems with management, demonstrating that the backups have happened, demonstrate that they're recoverable, maintaining the backup artifacts in a cost-effective way. That means cleaning of snapshots maybe, moving snapshots around to different regions to service our disaster recovery needs. These manual operations can be cumbersome in the cloud as well. Customers also tell us that it's expensive to build and maintain on-premise storage solutions. I probably don't need to tell the folks on the call this. Obviously, when we're trying to maintain infrastructure to back up and recover and protect our data assets, and the arrow for data storage and data management is always going up. We're always, in my experience, as time goes on, we have more and more data under management. The backup and recovery infrastructure needs to keep up with that. We're going to need to make predictions about data under management over the long period. We're building backup solutions with depreciation schedules of 3 to 5 years. So we're putting backup solutions in place that can protect a data workload that's variable and constantly increasing. This can add up to high costs as we're overcommitting resources in order to make sure, absolutely sure, that we can protect those data assets. And then finally, we have challenges with compliance, kind of a lot of different dimensions here. Obviously, when we're making backups, we need to maintain chain of custody of the backup artifacts. We need to encrypt those backup artifacts if they're leaving our on-premise locations, or it's also probably a good idea to encrypt them even if we never intend to have them leave our facilities. We need to be able to we need to demonstrate that we can recover from these artifacts, and of course, adding to the high cost, we need to maintain the capability to recover from backup artifacts that may be as old as 7 years old. So it can be difficult to meet our compliance objectives across all of those dimensions, especially as time moves on. So what are the benefits of using AWS for backup and recovery to meet these challenges? One are the AWS services that we're going to talk about today are well integrated with each other. So the compute infrastructure that we offer is built on top of and interoperates really well with the backup and the storage infrastructure that we're going to talk about. The features of the storage infrastructure that we're going to discuss today are exposed through APIs. We have comprehensive SDKs that we offer to allow for integration, both for you as a customer into your own applications, to other AWS services, and critically our partners can take advantage of these integration points to build solutions on top of these tools. At AWS, security is job one. At Amazon as a whole, security is job one. We build our storage solutions and our storage foundations with security in mind. Again, a couple different things I'd like to talk about here. One is that AWS is going to maintain the security and integrity of the physical infrastructure on your behalf. So we like to talk about this as a shared security model where AWS protects the integrity of the cloud, and the customer is then left to protect or to define the policy for access and how folks use the data in the cloud. So this is a shared model with Amazon taking the load, the undifferentiated heavy lifting of maintaining secure data centers, chain of custody for the bits, the physical bits as they live on physical devices, and you, the customer, taking advantage of services that we provide to control, monitor how data is used, to audit the life cycle of the data, and to really tightly control the data itself. This can make it a lot easier to demonstrate security as well. AWS services are built to be easy to maintain, so of course there's no need to maintain or buy on-premise hardware. We offer the ability to manage our services through a console. We offer tooling and libraries to use to maintain the life cycle of these services. And of course this can lead us into a little bit of an anti-pattern as discussed, where it may be tempting to manually operate these services, but as we move into production and we scale out, there's really a benefit to use some tooling to help us maintain these workflows. A key point with the AWS cloud, especially for backup and recovery workloads, is that it's a scalable infrastructure. This becomes important on the recovery phase. So ideally, and in my career I may not have always perfectly achieved this, the ideal recovery is one that you're doing and testing and ideally automating recovery testing. This is actually difficult to achieve in the data center, but it's a lot more achievable or realizable in the cloud, where I can make a backup and then demonstrate that I can recover to it automatically. The nice thing about AWS is that I can recover to servers, demonstrate that the recovery worked and that the tests were completely, and then hand that infrastructure immediately back to AWS, so I'm not paying for it when I'm not using it. Another way that scalability is important is that I'm not worried so much about building a data recovery platform that's going to be able to scale, 3 to 5 years down the road. The storage infrastructure that I'm using at AWS is going to scale with my use. I can add EBS volumes, I can make them physically larger, I can place assets in S3, all without making physical purchases, finding room in my data center, buying additional licenses, etc. And all of these together can really help lower cost. I'm going to pay for what I use when I use it. So what are some of the AWS storage services that I kind of realize all of these features and benefits? Kind of pride of place has to go to Amazon Simple Storage Service, or what we call Amazon S3. This is an object storage service designed to store and access any type of data in basically any volume. So an object is kind of defined by its access method. We have a key, which is more or less a file name, and a value, which is the contents of the file, or the contents of the object. In this idiom, it can be 0 length, it could be up to 5 terabytes in length, and we can store as many objects as we like with 11 nines of durability at the object level. So as you can probably tell, that's a pretty interesting capability for a backup and recovery system. An adjacent service is called Amazon Glacier. This is also an object store, so we have this idiom of a key and a value, but this is designed for cost-effective archival storage. So whereas Amazon S3 makes objects immediately available for download as soon as you upload them, Amazon Glacier is more appropriate for archival use, where I only have occasional use of those files, and I don't need immediate access to them after I've uploaded them. Talking about interoperability, Amazon Simple Storage Service, or S3, and Amazon Glacier can work together. So I can upload an object into Amazon S3 and then create a lifecycle policy and move that object over to Amazon Glacier when I'm sure that it's moved into kind of an archival phase of its life. So as an example, I can move incremental backups and full backups, store those in Amazon S3, and then move older full backups over to Glacier as they're no longer relevant for immediate recovery. A final solution that we'll talk about here today, and is especially relevant for N2WS, is Amazon EBS. This is a little bit different. This is a block storage service, so rather than kind of keys and values, we're talking about data in blocks. This is analogous to a hard drive or a USB volume, if you will, an iSCSI attachment. This is a network-attached storage volume for virtual servers, and specifically for Amazon EC2, the virtual service framework or service that we provide at AWS. So this is used for root drives, so slash or root on a Linux box or a Linux instance, C drive for a Windows instance, as well as additional data volumes for a database server workload for access for scratch space. Any persistent block storage can be provided by Amazon EBS. It's network storage as a service, however, so I can do additional things with it that it may be hard to do on-premise. I can snapshot it critically, so I can take a point-in-time snapshot. For later recovery, I can use that snapshot to build new server images, so I can clone an instance. I can move those snapshots around the world to different AWS regions to use it to inform a disaster recovery workflow. I can use those snapshots to build out fleets of cloned servers, again, worldwide or within the region. The snapshots are differential, so if I take two snapshots, the second snapshot is just going to have the changes that have been made between the first and second snapshot. So again, paying for what I use. The also interesting thing about volumes is that they're flexible. They provide a different performance characteristics based on need as well. So if I need them to act more like an SSD, I can use a GP2 EBS volume type. If I need to have them act more like a hard disk for throughput intensive workloads, I can use an ST1 volume type. And the nice thing is I can change their behavior, I can change their type even while they're online and through their life. So again, paying exactly what paying for what I use is the theme here. So what are the benefits of using AWS Partners for all of this? So AWS provides a pretty capable framework for backup and recovery. AWS Partners like N2WS provide easy configuration, the capability to assemble these tools for rapid recovery, essentially take Amazon EBS, the snapshotting capability that I could, if I needed to, operate manually, but really help me assemble that and operate long-term policy-based backups. So they've got an idiom and a workflow that they're really streamlining on our behalf to enable all of these additional features in a cost-effective way so that I can effectively manage it. And to speak more about that, I'm going to hand it over to Sebastian as he discusses Cloud Protection Manager from N2WS. So with that, take it away, Sebastian.
All right, well, thank you very much. All right, so operational backup and disaster recovery for AWS. Well, let's talk a little bit about Cloud Protection Manager. I think it's easiest if we start with what can go wrong with your IT infrastructure. Well, first off, obviously, there's attacks from the boogeyman, then virus infections, ransomware attacks, natural disasters, acts of God, which obviously are not preventable, and then you have the natural accidents, which could be preventable, but we all know it happens. A database admin corrupts a database, a system admin accidentally deletes an instance, and of course, general system failures, Patch Tuesday. Do I need to say more? So what can you really do to protect yourself from the calamities of life? Well, there's the basic standard way, doing them manually, the snapshots, but once you stayed up till 3 a.m. in the morning trying to prepare backups, you get tired of that real quick. And then there's scripting, of course, which is hard to learn, doesn't scale all too well, and cannot be easily delegated to different team members. But of course, that means job security for the scripting guy. And then, of course, there's the enterprise class solutions such as Cloud Protection Manager. So let's find out a little bit more about that. First, let's talk about delegation of responsibilities. So Amazon AWS is the section in yellow. That's the technical side, the security off the cloud. AWS will make sure that your emulated hardware works at peak performance. And then there's you. You're represented by the blue section, and you're responsible for the security in the cloud. See the difference there? Off and in, that's the part that makes you blue. Anything that can go terribly wrong, the boogeyman, the ransomware, the OS, the crashes, well, that's your responsibility. So why Cloud Protection Manager? Well, first off, it provides you with an easy-to-learn graphical user interface with a single pane of glass. Easy to manage granular policies which allow me to schedule backups anywhere from monthly down to the minute. And that seems crazy at first, especially coming from a traditional backup. That is absolutely doable in Cloud Protection Manager. Backups every 15 minutes, absolutely. And on top of it, there is no maintenance window necessary to achieve that. And Cloud Protection Manager provides operational backups in full-featured disaster recovery, which is purpose-built for AWS. Now, what does that mean? Speed, fast, that's what that means. We use the native snapshotting capabilities, and we recover in seconds from problems and even complete outages across AWS regions and accounts. And of course, on top of all of that, we provide extensive reporting and auditing to see what's truly going on in your infrastructure. So let me tell you a little bit more about N2WS. So we were founded in 2012. The first version of our product was released in 2013, which means we've been around for quite some time now. Consistently, we're at the top-rated backup solution in the AWS Marketplace. Our headquarters is in West Palm Beach, Florida, which probably means that's why we know so much about natural disasters. And our development center is in Israel. As I mentioned, we built on cloud-native technologies, and we're purpose-built for AWS. And we just simply distribute it as an AMI through the AWS Marketplace. So I think a picture does speak more than 1,000 words. So what I'm going to do now is I'll actually show you a demo of the product and how it works. All right, so what I'm going to do now is I'm going to share my screen. Well, in a moment, you're going to see my web browser. So really one of the first questions we usually get is, how do I get a hold of Cloud Protection Manager? Is this some software that I need to install, that I need to download? It couldn't be simpler. Cloud Protection Manager comes as a self-contained Amazon image. It's essentially an appliance that I can just simply pick up in the AWS Marketplace. That's one of the reasons why we're looking at my web browser. The first step is you need to figure out where would you like to spin up Cloud Protection Manager in your environment. The next step is click the Continue button. Then Cloud Protection Manager spins up in your environment. That process doesn't take a long time at all. It takes about 60 seconds. Once that's done, I can communicate with Cloud Protection Manager through our web portal, which is the other reason why we're looking at my web browser. As you can imagine, I already spun mine up, so it's configured already. Very first time you're going to spin it up, there's going to be a couple questions. So do you agree to the license agreement? Can we have your firstborn? And a couple other questions as well. We'll actually talk about that in a moment. What's important on this screen is that this username and password has absolutely nothing to do with my AWS credentials that I use to log into the console, which means the users who have access to the backups and the restores don't ever have to have any AWS credentials. So I'm not ever revealing anything off my environment. So what I'm going to do now is I'll log in. So this is what it looks like. I know it looks a little bit confusing at first, a lot of buttons, a lot of features, but trust me, you're going to be an expert after this in Cloud Protection Manager. First thing is you have this blue band, these tabs up here. The first one is Backup Monitor. It shows you a chronological list of all of the backups that Cloud Protection Manager has performed. And of course, I can start filtering this by policies, by different AWS accounts that we're targeting, and a couple other things as well. Next one is Schedules. So you define how often would you like to create backups. And as I mentioned, you can actually filter this down to particular minutes where you want to create these backups. The next one is policies. This is where we define what exactly do we want to back up. As you can see, I already have some for my Exchange, my Active Directory, my SQL, my RDS, my Linux. Of course, you can create your own policies as well. First off, you choose which AWS account we're going to be using for this particular backup policy. And I can even associate this with the user who's currently logged into Cloud Protection Manager. So this allows me to separate the duties of my users very clearly. And down here, this is where I choose how many generations of backups would I like to retain. So that's my retention period. And then I associate that with the schedule. How often do I want to back this up? So we're really just missing one thing now. What exactly do we want to back up? So over here, I already have a policy. On the right side of the screen, it's my backup target. So if I click on that, here I can choose now to add instances to this backup policy and anything that's attached to these instances. Of course, I can also choose volumes that aren't attached to anything, so standalone data, then RDS databases, Aurora clusters, and Redshift clusters. So let's say I'm going to click Add Instances. Here I can browse through my different regions that I have, and then I can choose which infrastructure I actually want to back up. And it's pretty simple. All I have to do is tick box this, click Add Selected, and I'm done. From that moment on, Cloud Protection Manager is going to create operational backups of all of these instances in the currently selected region. Now the problem with that is that that doesn't really take into account my disaster recovery. What if a region goes down? So we also have to take care of that situation as well. And we can. And we do this with this disaster recovery button right next to my backup targets. So if I select this, here I can choose, well, every so often, every X amount of backups, I'd also like to perform a disaster recovery backup into the following regions. And this could be multiple regions if you want it to be. My main environment is in Oregon, so I usually choose North Virginia for my disaster recovery. And down here, we have a really nice feature as well, because here I can even choose to perform a disaster recovery into a separate AWS account. That's exactly what we were just talking about. Not a week goes by where some account doesn't get breached, some user doesn't get hacked. Well, then what would happen if my AWS account does get hacked? Well, if somebody starts deleting my production environment and perhaps even my disaster recovery backups in another region, then what am I left with? So here I have the opportunity to create a disaster recovery in a separate AWS account that nobody has access to. Terrible things happen. All I have to do at that point is simply spin up the instances in my disaster recovery AWS account. So that's a really nice piece to have just for peace of mind. And if you really think about it, it doesn't cost you much. These AWS accounts, well, no instances are actually running in this account. It's really just storage that you're using in that account. All right, I would say let's actually perform a recovery so you get to see what that looks like. All right, so let's say one of my file servers goes down. So I'm going to start filtering this for my file servers. Well, next one is I'm going to choose my most recent backup, and I'm going to hit that recover button. Now, because we configured disaster recovery, that's why I see all of these menus up here. So I can choose to restore this into the region where it originally came from, or I can also choose to recover it into my disaster recovery region. And any other region you would have selected would show up here. Because we chose disaster recovery into a separate account, well, I can also restore it to that separate account if I want to. Because we now have a disaster recovery backup in our separate AWS account, I could even choose to restore from that account. And these menus are completely mix and match. Any crazy configuration that you'd like to spin up, you could. So let's say I want to recover from my separate account into my original account, into my disaster recovery region. Absolutely, that's doable. I can actually make that happen using Cloud Protection Manager. Now here on the right side of the screen, that's my actual recover button. The first one is instance recovery. This is going to spin up a clone instance off my backed up instance without even touching the original instance. Now you're probably wondering, why is this a feature I would want? Well, because Perhaps you're still performing forensics on your machine that was hijacked, that was invaded by viruses, that crashed. So you're still performing the forensics, but in the meantime, of course, the production environment has to be up and running. So that's the feature I would use then. To the right of that, volume recovery, just as the name would suggest. So in this case, we're going to recover the volumes and automatically attach them back to the instance where they came from. Now I only have one volume attached here, but if I would have several, you would just simply see a list, and with surgical precision I could choose which volumes I actually want to recover. Well, it's pretty simple. All I have to do is switch attach volumes, delete the old ones, and attach this to my server and recover volumes, and I'm back in business. The huge advantage of going this route is that nothing really changes as far as the server is concerned. VPC doesn't change, subnet doesn't change, IP address doesn't change. Even the connection string to a database wouldn't change. Everything stays exactly the same. And I usually visualize this for customers is, think of an old-fashioned physical server. Hard drive crashes, terrible things happen, ransomware. Oh, I'm just going to pull out the hard drive and replace it with my backed up hard drive. That's exactly how this works as well. And then next to that, last but not least, we also have another button, Explore. This makes sense because this is a file server, so it could happen that somebody comes up to me and says, hey, we're creating backups and I lost a couple files, a couple folders, can you bring them back? Well, yes, theoretically, but I'm not going to do an instance recovery for a few folders and a few files. I'm not going to do a volume recovery for that. But Explore allows me, or it allows Cloud Protection Manager to actually drill into the currently selected backup without me having to spin up a server, and I can actually just retrieve the information that I need out of that backup. Now here I can browse through this information. Keep in mind, I'm right within my web portal. And yes, this happens to be a Windows server, but it really doesn't matter at all. Cloud Protection Manager is completely OS agnostic. It doesn't care if it's Linux, it doesn't care if it's Windows. It sees your instances and backs them up with everything that's attached to it. It can even back up encrypted volumes, and it can even perform backups and recoveries of encrypted volumes across regions and across accounts without me having to worry about the keys. All right, I would say let's actually perform a recovery so you get to see that as well. So what I'm going to do is, we did talk about database servers, so let's do a database recovery. Linux farm policy. So I'm going to click recover. That actually contains my database server. In this policy, I have more than one machine. So here I have my Apache and my SQL. Right, so I'm going to click instance recovery now. Got a few more options here. I can choose to spin this up into a different AZ, different VPC, different subnet, assign it to a different security group. Maybe we always talked about we needed to change the instance type. Why not do that as we're performing the recovery? I can actually make that change right here. I don't use static IP, so let me get rid of that. And here's my recover instance button. Right, so I'm going to click this button now. It's going to ask me, are you sure you want to do that? Absolutely. Let's click the OK button. We're going to get another message right after that. Operation succeeded. One instance was launched. Now, if we're quick enough, I can actually show you what that looks like within my AWS console. So if I refresh this, we can literally watch the restore of this machine right here. It's still pending, so this is why this button is still yellow. It's probably going to stay like that for another 20 seconds or so. The moment that button turns green, that machine is fully functional and operational because of a feature that Amazon calls the lazy loading feature. And that's pretty useful, especially for my SQL server, because immediately when it's up and running, it can actually start accepting transactions without me having to wait for a really long time. And that's about the time right now. So now it's green, up and running, even though my status checks are still running. So really from the moment that instance needed to be recovered to the moment that it's fully functional and operational, about 1 minute. A couple other things that are interesting as well, because I did mention a couple times now different AWS accounts. You can actually define them in Cloud Protection Manager. See up here under Accounts, my Cloud Protection Manager has access to 4 different AWS accounts. So this is push and pull, which means I can actually reach into different AWS accounts, perform backups, and also push information back and forth between these accounts. Now you're probably wondering, okay, so then what's users for? Well, remember when we logged into Cloud Protection Manager, here I can define who actually has access to Cloud Protection Manager and what can they see and what can they do in Cloud Protection Manager. We have the ability to create different types of users, independent and managed. I just simply created 2 users named independent and managed. Independent users, well, those are my power users. I trust these guys. I can create quotas for them, so I can just start filling up my entire AWS account with terabytes of data. They also have the ability to create their own policies, create their own schedules if they'd like. And of course, me as the admin, I have the option to define what are they allowed to do. Are they allowed to do file-level recoveries? Are they allowed to do regular recoveries? That sort of thing. They have their own little realm within my Cloud Protection Manager, so I can define what they're allowed to see even within Cloud Protection Manager. Managed users, very similar. Everything that I just described applies here as well. With the added bonus, there are users with little training wheels. I can manage them as the admin. It means I can create policies for them, I can create schedules for them, and I can even include them into my reporting and my auditing. Because that's an important part, right? Because my boss might be calling saying, hey, can you tell me what a certain user's been up to in our environment? That's what these audit report buttons are for. So I can very easily create an audit report, and I can see if somebody logs in, if somebody logs out, does a file level recovery, deletes items, moves items, make changes to the configuration. Anything they can do within Cloud Protection Manager is audited as well. So if you do have a disgruntled employee who's doing things they shouldn't be doing, well, you would very quickly find out about that through the auditing. This is per user. But of course, I can also do the same thing for my entire user population. See right here at the bottom, audit report for all users. If I'm not entirely sure who I'm looking for, but I do know what action I'm looking for. Here are all of my reports in this row. So if I need to prove to an auditor that we're actually performing backups, I can certainly do that. I can drill this down to particular instances, their volumes, and even down to the snapshot level if needed. Then all of that is also combined with notification. We use Amazon SNS for this, which means daily summary, everything is going fine, works. On the other hand, if things aren't going so fine, maybe we're trying to perform backups of regions that currently aren't available, that would trigger an alert, and you would immediately find out about that. Regions down, always a terrible thing to talk about. But let's play devil's advocate for just one moment. So Cloud Protection Manager, as I said, is an appliance which sits in your AWS account. Great, fantastic, because it belongs to you, which means also your backups belong to you, which means nobody gets to see what you're backing up. Nobody's going to see the structure of your corporation. Now let's say, though, Cloud Protection Manager is hosted in my AWS in a region. What happens if that region happens to be the one that goes down? Well, that's pretty bad. So then how do I get my Cloud Protection Manager back? Well, you can configure Cloud Protection Manager also perform backups of itself. But it's actually hard-coded into the product. You don't even need to configure this. But I can configure disaster recovery. So I can say, well, yep, also perform a disaster recovery backup of my backup solution into my disaster recovery region. Terrible things happen, okay. So if Cloud Protection Manager is down, how do I get it back? Well, simple, just spin up Cloud Protection Manager in your disaster recovery region. As we said, it takes about 60 seconds. Remember all the way in the beginning when we talked about it's going to ask you some questions? Well, it will give you the option to actually import old data as well. And if I do that, the import takes about 30 seconds. So spinning up plus import about 1.5 minutes. At that point, everything you see on the screen right now, backup monitor, policies, schedules, configuration, everything is going to be up and running, including your recover buttons. And that's really where Cloud Protection Manager scales extremely well. Because once you start recovering, you can actually recover several different instances simultaneously. So that recover time, well, it doesn't matter if we're recovering one instance or if we're recovering 10 instances. The time stays exactly the same. So truthfully, you can spin up your entire production environment in less than 5 minutes. And that's also another thing about Cloud Protection Manager. Don't just think of it as a backup and restore utility. It's also a cloning utility. Think of staging environments. Everybody should have one, but hardly anybody does. And if they do, it's hardly ever in sync with the production environment. Well, If I'm using Cloud Protection Manager to back up my production environment, then what's to keep me from using it to create a staging environment based on my production environment in another region or in another account? Once I'm done, I'll just simply shut it down. So that's a very high-level overview of Cloud Protection Manager. Mike, can I hand it back to you?
Absolutely. Thanks, Sebastian.
Hi, how are you?
Howdy, Briley. And so we're looking at the Goodwill Industries slides, so take it away, Briley.
Got it. So hello, everybody, and thank you for joining us today. My name is Briley James Yetter. I'm the Director of Technology for Goodwill Industries of Southern New Jersey and Philadelphia. And before I get into the wonderful technology and support that Amazon Web Services and N2WS has offered us, I'll talk a little bit about Goodwill Industries. We were founded in 1902. We're a network of 162 independent community-based organizations scattered across the United States, Canada, and multiple other countries. Last year, we served more than 37 million people and placed over 313,000 people into employment. And across all of the Goodwills internationally, we generated a revenue last year of a little more than $5.71 billion. Retail sales were $4.16 billion, and grants, gifts, endowments, donations was $1.55 billion. As far as our territory goes, with respects to Southern New Jersey and Philadelphia, we did about somewhere between 50 and 60 million last year. So obviously, with that being stated, technology is very important to us, and we need technology to continue to run and continue to grow. A little bit about how we're set up. We've got about 45 locations total. We have 3 to 4 schools and training centers where people can get college credits. They can earn their GED, and we also do a lot of job placement. We do Microsoft certification. We do CDL training. We have 10 donation centers with one on the way in Shrewsbury, New Jersey. We have 2 to 3 large distribution centers. We have a corporate office and 2 other smaller offices, and we have 25 stores with an additional store on the way. So before AWS and N2WS, when I started with Goodwill, the first thing I wanted to do was look at what we had and do what I could to protect our assets. And also protect our data. And during the presentation that Mike and Sebastian gave, there was a couple of things that came to mind. And that there's words that stuck right out, and they were stability, reliability, ease of use, centralized management, and peace of mind. And when I started with Goodwill, we had physical assets, servers, data scattered on aging servers at multiple locations. We had servers that were being infected. Goodwill was hit with ransomware a couple of times. We were manually switching and replacing and managing backups. We were having to sift through backup reports every morning. There was the depreciation of hardware. There was just a lot of risk, a lot of responsibility, and a lot of exposure there to Goodwill. So the first thing we wanted to do was move all of our assets to Amazon Web Services. And then the second thing we wanted to do is we wanted to look at how do we protect this data and also prevent disaster. So that's when we found N2WS. And I can tell you that since moving to Amazon Web Services and since setting up our backups with N2WS, we haven't had any outages, we haven't had any issues, and there's been that peace of mind which you really can't put a price on. When you're dealing with the management of 45 locations and you have the stress and the load of the entire organization looking at you to make the right decisions and make the right recommendations on protecting their technology and their intellectual assets and their data, you know, you want to try to move as much off as possible to vendors who you know are proven and you know can help you. And AWS and N2WS have definitely done that. So Just to give you a little bit of background on the environment and what we're doing and how we're using AWS and N2WS, most of our infrastructure is in the Virginia AWS environment. It includes about 27 server instances in EC2. We've got 47 volumes, and we have almost 5 terabytes of protected infrastructure, which doesn't even begin to include the archive data or protected data in snapshots or living in Glacier. This environment includes a centralized ESET antivirus server. It includes a unified centralized wireless and networked equipment controller. It includes the Cloud Protection Manager server itself. It includes front-end financial systems. It includes back-end financial systems with databases. 4 redundant point-of-sale front-end application servers, redundant donation kiosk systems, a small testing environment. It includes redundant domain controllers, redundant front-end barcoding and inventory management systems, redundant gateways, redundant connection brokers. It's got a SharePoint farm and SQL reporting services. We've got 2 front-end web servers, and we have a slew of back-end SQL 2012 servers holding the databases for our point-of-sale systems, donation systems, barcoding systems, and our SharePoint farm. All of the servers are Windows Server 2012 R2, with the exception of the Unify and CPM servers, which are Linux instances. So that's a little bit about our environment. And when we talk about backup and disaster recovery strategy, we've got multiple policies set up, and I know Sebastian touched on it, but just to let everybody know what we're doing here, we're doing hourly snapshots of all of our servers that contain mission-critical data and frequently changing data, including the back-end point-of-sale systems, the financial systems, the SQL servers, and the SharePoint farm. And as Sebastian had mentioned, you can really set that up for almost any frequency you want, down to a couple of minutes, but hourly is that meets our needs. And then I'm doing daily snapshots of all of our servers that have static data, or they have infrequent data changes, including the domain controllers and our AV server, our Wi-Fi controller, and some of our front-end application servers. On top of that, I'm also doing daily policies, which hold, or I'm sorry, the hourly and the daily policies will hold snapshots for 2 weeks worth of generations. And then outside of that, we have a policy where we're backing up our servers on a weekly basis. And then we have a policy where we're backing up the servers on a monthly basis and then a yearly basis, with the idea and the end goal being to give Goodwill a 10-year retention policy and all that data. We've also configured our Virginia data center for DR, which those options, as Sebastian had mentioned, are readily available in Cloud Protection Manager, which sends the last snapshot of each one of our instances on a daily basis off to Oregon on the West Coast. So if, God forbid, something happens to the East Coast, our data and our entire infrastructure is basically sitting in cold storage, ready to be spun up at a moment's notice. I know Mike had mentioned it earlier, and I figured I'd touch on it here as well. When you're dealing with a traditional backup solution, there's always the space and the stress in adding more space and the ever-growing cost. And through working with CPM and AWS, we really removed that overhead where, and I go back to the words that I mentioned with stability, reliability, ease of use, and peace of mind. But this is another word that comes to mind, is scalability, and we're able to add space as needed, and we don't have to go back and delete older backups, which then destroys your retention. And then when we don't need it anymore, we can move it off to archive storage. So that's been really nice for us as well. And again, you really can't put a price on peace of mind, and AWS and N2WS have really given me that. And again, with the amount of stress and the amount of other things that we need to worry about as an organization, making sure that our infrastructure is safe and making sure that our data is protected is not something we really need to worry about with these 2 partners. We've had success with recoveries as well. I've been able to recover individual files successfully and within moments. We have a yearly disaster recovery drill that we need to perform to meet our CARF compliancy and to meet the requirements of our auditors, and we've been able to successfully spin up snapshots backed up through Cloud Protection Manager within moments, as Sebastian showed you. The only thing that we have not done yet is a full disaster recovery of spinning up the entire environment on the West Coast, but I would suspect that it would work successfully. I think that's all I have today, so I will pass it back over to Mike with AWS.
Thanks a lot, Briley. This is Mike. So at this time, we've got about 10 minutes, maybe 9 minutes left for Q&A. We've got a lot of great questions from the chat, but just a couple things I wanted to touch on that really popped out after listening to Sebastian and Briley speak. So as solutions architects, we're often working with partners and customers and really trying to drive in these best practices around account management, around audit, around kind of discoverability of assets. A lot of these things don't add much cost to the environment, but they could be technically difficult to achieve. And again, if we're attempting to do these things manually, which we see folks attempt to do, it can really result in quite a lot of work. And so I love to see solutions, and I love to bring and talk about solutions like N2WS Cloud Protection Manager, which really solves the problems of policies, scheduling, making users or giving users access to the recovery environment without necessarily giving them access to the AWS environment, using images and snapshots to do file level recovery, exposing logging artifacts, really helping guide those conversations with auditors. Really a fantastic capability. Anyway, I'll get off my soapbox there, but I really love to see solutions like this. Let's look at some of the questions in the chat. So this would be I think a question for Sebastian, and I think we touched upon it already, but Cloud Protection Manager, they're asking for the support for other AWS services. So specifically the question was around RDS Aurora, the relational database service with the Aurora engine. Does Cloud Protection Manager support RDS Aurora?
Yes, absolutely. It works exactly the same. I can create my policies. I can do recoveries within just a minute or two. So it works exactly the same way. Just what we just showed with the instances works just fine with RDS and Aurora and Redshift.
Okay, awesome. And yeah, I did see Redshift on the list there as well. And probably important to talk about, so AWS is listening to customer feedback. We're innovating and driving new solutions into products like RDS, and it sounds like CPM's right there, and N2WS are right there supporting those additional services as they're launched, an important part of the relationship. Here's another question about where the backups are stored. So I mentioned the affinity or integration between services, and kind of talked about S3 as having pride of place. We really didn't talk about it much after that. S3 is actually a foundational service that sits underneath EBS and is actually the engine that stores snapshots and kind of drives these recovery processes. So, Sebastian mentioned lazy loading. Where are we lazy loading from? We're actually hydrating these EBS volumes from S3 in the background. Here's a question about the location of the backups. So I think we saw a capability to do file level recovery. Where physically are these backup artifacts stored and managed, Sebastian?
Oh, that's actually a great question. That's why I always tell people Cloud Protection Manager belongs to you. It's your appliance, and your backups belong to you as well. So this isn't a SaaS solution. We don't have your backups. They're within your AWS accounts right underneath the snapshot. So if I would go into my AWS account, click on snapshots, I can literally see my backups. I don't have to figure out anymore what these snapshots belong to, but if I wanted to, we even tag them accordingly. So you would see, okay, this is a snapshot which belongs to a certain backup set. It's going to show you the policy, which machine was being backed up, which volumes are attached to that. So it's very easy to see, and I'm always in control of my own backups. Nobody else has access to them.
Okay, great. So it all stays within your own AWS account.
Right.
Let's see, I have another question here about backup policies and kind of maybe dynamically generated. So as we add instances to the environment, Sebastian, what's the process for pulling those instances into a backup policy?
Oh, that's a great question as well, because just as I said, I mean, if you wanted to use Cloud Protection Manager to spin up instances, to clone instances, or if I'm, like you said, dynamically spin up instances, how do I include them? Does that mean I need to go back into the policies, into my backup targets? Not at all. We can actually configure Cloud Protection Manager to automatically include instances based on tags. So all you would have then is a tag, it's a Cloud Protection Manager tag in your AWS, and you just simply spin up these instances with the names of the policies that you want Cloud Protection Manager to use to include them. It's essentially set and forget. You just set it up and Cloud Protection Manager will handle the rest.
Awesome. Here's another question that I'm sure is kind of on the top of everybody's mind these days, and this is around ransomware and kind of protecting ourselves from ransomware attacks. And I think specifically the attack vector where a ransomware, a virus may encrypt your data, then offer you, some option to decrypt your data, I guess. So we should say that EBS and S3 and a lot of the other AWS services provide server-side encryption. So this is transparent encryption that ensures that your bits, when they're placed on the backing store, when they're on the physical device, are encrypted using keys that you either allow AWS to control or you can control, or kind of a blended solution. Again, kind of choice is king here. We really want you to encrypt and maintain your backup chain of custody, the chain of custody of your data in a way that makes sense to you and meets the needs of your business. Of course, you can also encrypt the data before you place it on disk, and that using software constructs. And I guess this is what ransomware does. But maybe, Sebastian, you could take a minute to walk us through kind of how to protect yourself from this particular ransomware vector.
Yeah, absolutely. Well, the idea here is that I have the ability to create backups very quickly. There is no maintenance window. I don't actually need to shut down my system, do this after hours every once in a while. I could literally take backups of my entire system every few minutes. Once this terrible thing would happen, I can easily spin back the clock to exactly the time before I caught something bad, before I was actually hijacked. So this would allow me to very quickly recover my entire environment if need be.
Okay, awesome. So we're basically going to just kind of roll back the clock to the point in time before the attack occurred and kind of recover our data from that point. So and this kind of brings up something that I noticed as well that I thought was a really key point, in that Briley talked about scheduling hourly backups across a fleet of EC2 servers and then keeping them for a period of weeks. And so he's maintaining the capability and using differential backups, so differential snapshots. This may be a relatively cost-effective solution, but he is in fact maintaining a capability to set the clock back to any hour within a few week window. And what really struck me is while I could probably do this manually, maintaining the resulting tens of thousands of snapshots maybe wouldn't be a super fun job. So
exactly, right.
I think that's the capability that we're talking about.
Well, also I think what's important here is, I should just put a little bit more color to this. You even have the ability, as I mentioned, not just create a snapshot vault on your current account, but even create a vault of your data on a completely separate account that literally nobody has access to. So once you're setting this up, just create an AWS account that just you and the CEO and maybe one other person have access to, seal up the information, put it in a safe, and something happens, you just simply open the envelope and have access to your entire production environment.
Right. This is actually a best practice, and I'm really glad you mentioned that, Sebastian, because this is a best practice we talk about, creating an AWS account just for backup and recovery to place those critical assets that you would need to recover that's in an entirely different administrative domain. And so it's essentially a write-only location where we place backups, but the first account has the access to write backups, but it does not have the ability to delete backups or remove backups. We create policies on the second account to do that. And so even if we lost control of our first account, then we could use the second account to recover. That's a pretty important capability and relatively difficult to achieve manually. Okay, and so we are at the top of the hour. So next steps, really, AWS is an on-demand infrastructure. N2WS can be deployed in your account within a few minutes, as mentioned, so really encourage you to just go take a look. You can explore this product on your own terms and find out what it really does for what it can do for you. So you can navigate to the marketplace, which is a location for one-click deployment of a lot of partner tooling. You can learn more about N2WS on AWS at the AWS microsite on the n2ws.com website. And of course, you can always try AWS for free using our free tier. Feel free to go sign up at aws.amazon.com and get started today. So with that, thank you very much. We'll see you next time.